My name is Kathy Griffith, and I'm with the Griffith Family Foundation. My husband, Greg, at the age of 50, died from pancreatic and liver cancer, adenocarcinoma. So Greg and I were high school sweethearts. Went to Hollidaysburg High School together, never sick a day in our life. Kia in the audience witnessed our life. And we lived the normal life, and a beautiful life, as Greg called it, a fairy tale. And so, the end of January 2010, Greg was playing basketball at the building 2. And Greg played high school basketball at Hollidaysburg, college basketball in Erie, and then continued to play in all the men's leagues locally here at Mansion Park and, building 2. So he was playing, and he said he scored 30 points on that Saturday. And 4 o'clock, we had gone to church, and he looked yellow to me. And as soon as we got out of church, his eyes were bright yellow. I mean, they were terrible. And so I'm a dental hygienist, and I thought, more than likely it's probably a stone in the bile duct. I really wasn't real concerned. I just told Greg, Monday, you got to get to the doctor. You need some lab work done. So he went to the doctor, and the doctor put him in the hospital on Monday. By Wednesday, here at Altoona Hospital, he was told he had stage 4 pancreatic and liver adenocarcinoma with a life expectancy of about 2 weeks because it had already metastasized. So, what do you do when we have our 2 sons, Jordan and Jamie? One is a freshman at Penn State and one is a junior at Penn State. Do you curl up in a ball, never come out of your bedroom, or do you fight back? So Greg's response was to the doctor, Blair Gastro here in Altoona, Dr. D. Francisco and Dr. Ralph McKibben. Blair Gastro hooked us up with Dr. Moser and Dr. Zay at UPMC, and Greg said to Dr. Moser, hey Doc, I know you can't do much for me, but Doc, what can I do for you? Big words. What can I do for you? And Greg embarked with our friends, our community. Our foundation has raised to date in 3 years close to $200,000 for the pancreatic research efforts of Dr. James Moser, formerly of Pitt, now of Beth Israel Deaconess Harvard Medical School. So by Greg's movement, by Greg's thinking out of the box, not wallowing in all of his pain and angst, he decided that he was going to make good out of the ugly. And so what you're witnessing here today, it'll be 3 years in August that Greg it was 3 years in February that it was diagnosed, 2 years in August since he passed. Our family, our friends, our community have done what Greg would call a full court press on pancreatic cancer. So, chain of events. Greg passes. Dr. Moser gets promoted to Harvard Medical School. My aunt that we stayed with in Pittsburgh all the time reads in the Pittsburgh Post-Gazette an article about a 9th grader that has come up with an early detection test for ovarian, pancreatic, and lung. And Jack had won the Intel Science and Engineering Fair, which is a big science fair held internationally for 1,500 of the most intelligent high school students. Jack won first place, $75,000 for his early detection test of pancreatic, ovarian, and lung. And so I'm not going to go into detail. He will go into more detail about how he did that, and about the thing with Jack is our same story. He witnessed a close family friend die of pancreatic cancer, and it's awful. 50,000 Americans a year will die of pancreatic, and we all are a target. I knew nothing about pancreatic cancer. Now I realize that the time is now that we really bury this thing And so Greg and I felt through our faith, through our family, through our community, we could work together to bring this down. And so today is really, in my opinion, Greg kind of foreshadowed all this as he talked to us. He made it well over 19 months. So instead of the 2 weeks that everyone thought he was going to get, he got 19 really good months. He did close to $1 million worth of treatment. He was employed here at Penn State University in the Business Outreach Department. He really fought this by going to talk to Rotary clubs, Kiwanis Club. I couldn't keep up with Greg. Seriously, his schedule during the pancreatic cancer, I couldn't even keep up because he felt he needed to tell people that, always have hope no matter how bleak something looks. So getting back to Jack, my aunt gets that little piece of little article in the Pittsburgh Post-Gazette, gives it to my mother, and next morning I get an email from Jen LeConte, our friend, and it said, Dr. Moser and Kathy, what are your thoughts on Jack Andraka? Dr. Moser said, I haven't heard about him. And I said, I just heard about him last night. Dr. Moser says, Kathy, get me technical details. Now, seriously, he's at Harvard. How am I supposed to? I'm a dental hygienist here in Altoona. So I just pick up the phone, dial information, and lo and behold, Jane, his mother, picks up the phone, and Jack came to our event at the casino in Lakemont in July, talked to a group of 600 people at the casino about his early detection test and about bringing hope to our world. So today we have a wonderful panel. Jack Andraka, of course, Dr. Ralph McKibben of Blair Gastro, and Dr. Cyan Zhang of Penn State University and Cancer Research. So I'm going to bring to the mic first Dr. Ralph McKibben. He is the state chair for the Digestive Disease National Coalition and our cancer rep here in Altoona at the Altoona Hospital. Thank you. Okay.
So here you are in an entrepreneur center talking about pancreas cancer. What the heck is going on? I mean, everybody wants to meet Jack, and this is pretty cool stuff. But I want to take a minute to talk about what's really going on here today. I want to see if I can pull up this PowerPoint. Yep, wrong one. Do we have any technical help here today?
Yeah, I got it.
Thanks. Okay, just real quick, we're talking about pioneering research advances on cancer in an entrepreneur center. And so I am the cancer liaison at the hospital to the Commission on Cancer. I'm the Pennsylvania representative to the State Leadership Cabinet, the Pennsylvania representative to the Digestive Disease Coalition. I'm the director of operations of our practice here. Blair Gastroenterology covers an area of about 500,000 people. And so the opportunity, I also participate over here in the Sheets Entrepreneurial Center on their advisory board. There are new business models coming out, new interactive models, which I'll get into, and progress for change. And some of this is intuitive to people your age, not so intuitive to others. How did Google grow so fast versus the typical business, even like Sheets? Started in the 50s with a couple stores down the road. Sheets Google came up overnight, and it's one of the biggest companies in the world. So there are things going on and alliances being created. Entrepreneurship doesn't just mean starting a business. There's social entrepreneurship, there's nonprofit entrepreneurship, and it's about innovation, change, and creation. So the center was actually happy to use the resources to bring you all here today. Some of you may be interested in being entrepreneurs. Business is one aspect of that, but also looking at some of the opportunities for change here. I'm just going to review pancreatic cancer in general. Why should you care? I always say when I give a talk, who, what, where, when, why, and why do I care? I mean, nice when people talk about things, but what does it have to do with me? So I'll just review that quickly and then talk about the modes of change, and then we'll move on to the next part. This is the roll of fame, I suppose, for pancreatic cancer. Luciano Pavarotti, the famous opera singer, Henry Mancini, Frank Herbert, the writer, Jack Benny, old-time comedian, von Neumann, the mathematician, Steve Jobs, Mr. and Mrs. Carter down there on the bottom, Michael Landon, old-time actor, Patrick Swayze from Dirty Dancing, and Sally Ride, the astronaut. All people struck down in really fairly young age, most of them with pancreatic cancer. Back in 1971, Richard Nixon, as president, launched an official, quote, war on cancer, saying that he would appropriate $100 million to launch this campaign and find a cure for cancer, basically paralleling the efforts of Jack Kennedy when he said, you know, let's go to the moon in under 10 years. So that was the idea. And for you who don't know, 100 million was a lot of money back then. Not 10 minutes of the federal budget. Vincent DeVita, who was director of the National Cancer Institute, gave a talk in 2005, and he said that the war on cancer did everything it was supposed to do. It supported basic research, it started the idea of clinical trials both here and abroad, and the cancer incidence started dropping in 1990 and has continued to drop every year since. So he says the benchmark has been hit, and that's proven in this graph where you see, oh my gosh, you know, mortality rates are going down. This is what you hear on the news. Cancer's going down. So why do I care? This is an example of colorectal cancer. These are major cancers: breast cancer, colon cancer, and childhood cancer. The new line that went up there, which unfortunately is again the purple color, is pancreatic cancer. It's not going down. In fact, it's going up. The top 10 cancers in the United States and in Pennsylvania are shown here. Pancreatic is number 10 in your risk of getting it, but it's number 4 on the death list. So this is the 4th most lethal cancer. It's going up in incidence, which is shown in the red bars, so statistically significant rise every year. And if you look at the graph, there's a nice bend in the national numbers, and even in Pennsylvania, the risk is going up. So if you look at the graphs here, and I just extrapolated that out in a quick fashion, I'm sure it's not mathematically correct, you're looking at about 10 years from now that pancreas cancer will be more likely to be a cause of death than colorectal cancer, okay? And even breast cancer probably in 15 to 20 years. So this is your future. This is what's going to hit you when you get to be my age. This is why you should care. It's something that you need to know about in your lives. This is just Pennsylvania data showing that really we're the same as the rest of the country. So the pancreas is that organ. It looks like a fish fillet behind the stomach. It puts out not only insulin, but it also does the digestive hormones and regulates the digestive activities. Risk factors are age, overweight, obesity, smoking, family history. African Americans have about a 50% higher risk for unknown reason. Chronic inflammation diseases, and unfortunately blood types AB or AB are more likely to get it. You can acquire some risk factors, being obese, having chronic pancreatitis from smoking or drinking. Other things such as H. pylori infection, hepatitis B, and lousy diets are also involved. There are some hereditary factors, which is only 5 to 10% of all cases, so basically 90% are what we call sporadic. There's some genes that we're looking at, etc. Staging, we don't really need to get at. What we do say is there's low survival rate. Less than 10% of patients are confined. They're likely to have a short lifespan when they're diagnosed. The Agency for Healthcare Research and Quality, which is about advancing excellence in healthcare and measuring outcomes, does not recommend screening for pancreatic cancer in people without hereditary risk factors because we don't have any good testing and we can't identify who's at risk, and tests are expensive and shouldn't be done unless the risks and benefits are there. Cancer Control Planet, which is a website, international organization, where you plan, act, network, and do evidence-based research to treat and use tools for outcomes, has programs out there really initially designed for Third World and World Health Organization, but has been altered and put in. This is a paper by Jeffrey Harris that was published last year. It's a summary paper talking about a framework for disseminating evidence-based health promotion outcomes. And the idea is, how can we promote change through an entrepreneurial approach without using the old-fashioned technique of the researcher publishes a paper, he presents it at the meeting next year, his colleagues talk about it, maybe repeat it, and another year or two things happen, and then the regular people get to it, and you're looking at 5 to 10 years before anything happens. The idea then, and this is a working model that's been studied, is that researchers and disseminating organizations such as the Griffith Family Foundation, the Association of Families Fighting Pancreatic Cancer, and others will combine and talk to each other and find their common interest and common goals and work together. By networking and hooking up with other people, and this is an important consideration, using social networking. You will interact with user organizations, which is really defined as those who care or need to know. Physicians that treat patients, people with high risk factors, people with family that are involved, people that are worried about it, nurses, hospitals, etc. And there's a to and fro and a back and forth model. It applies to business change and business growth, but also can be used for social entrepreneurship and healthcare outcomes. So what you're looking at today then is the researchers, the disseminators, and the user organizations coming together. Some of you will be users. All of you will have family members affected in some way. Remember, we're talking about the 4th leading cause of cancer death, and in your lifetime will be number 3 or 2 unless we change things. So it's going to affect your lives. So this successful dissemination of evidence-based practices has a cascade on the user side, of course, adopting it, implementing, maintaining, and feedback back and forth. And we don't need to get into those details, but I just want to say that the Entrepreneur Center here in this spirit is helping not only just business, but community change and outright other things going on. So there's a lot to be looking at. Some of this, I said, is obvious to you through your social networking tools that businesses are starting to do. But this is a tool available to you when you look at your life and you want to make changes in the future. And on that, I will move ahead. Thank you.
Okay, and now I would like to take the opportunity to welcome Jack Andraka. Now that Dr. McKibben has given you kind of the whole process of, pancreatic cancer, what people that like Patrick Swayze, and a lot of these people like Greg are stricken in the prime of their life. And again, as Dr. McKibben stressed, there's a real urgency to really want to move the ball up the court, as Greg would say, because it's going to move from the 4th leading cause, possibly to the 2nd leading cause of cancer death within your lifetime. We're looking at probably between 2015 and 2020. We're all going to know of more people with pancreatic. And so, there's a real push for an innovator like Jack, that we all really start raising the awareness here in our country about, getting a cure, or at least making it a treatable disease. So it is my pleasure. Jack, I don't know if many of you have seen, but he's been on Smithsonian Magazine as a innovator, rocking our world, been on CNN, NPR Radio, ABC News, 60 Minutes is going to do a piece on him, Forbes Magazine. I mean, the list goes on. He is an international sensation because this young man took the negative of watching his friend that he called uncle pass from pancreatic cancer, and he decided to do something about it. And so it is my honor and privilege to welcome to the mic Jack Andraka.
Have you ever experienced a moment in your life that was so painful and confusing that all you wanted to do was learn as much as you could to make sense of it all? Okay, let's figure this out. 1 second. Oh no, wrong one. Okay. When I was 13, a close family friend, who's like an uncle to me, passed away from pancreatic cancer. When the disease hit so close to home, I knew I needed to learn more, so I went online to find answers. Using the internet, I found a variety of statistics on pancreatic cancer, and what I had found shocked me. Over 85% of all pancreatic cancers are diagnosed late, when someone has less than a 2% chance of survival. Why are we so bad at detecting pancreatic cancer? The reason our current modern medicine is a 60-year-old technique. That's older than my dad. But in addition, it costs $800 per test and is grossly inaccurate, missing 30% of all pancreatic cancers. Your doctor would have to be ridiculously suspicious that you have the cancer in order to give you this test. Learning this, I was sure there had to be a better way. So I set up a scientific criteria as to what a sensor would really have to look like to actually effectively diagnose pancreatic cancer. The sensor would have to be inexpensive, rapid, simple, sensitive, selective, and minimally invasive. Now, I was pretty sure I could do this, but I wasn't quite sure how. So then what I found is the reason our current test hasn't been updated in over 6 decades is because what you're looking for is this tiny amount of protein in this vast amount of blood that's already abundant in protein. And so it's almost as like you're looking for a needle in a stack of nearly identical needles. However, undeterred, I went to any teenager's best source of knowledge, Google and Wikipedia. And I found a database of over 8,000 different proteins that are found when you have pancreatic cancer in your bloodstream. And I just began going through these, seeing which ones would be working as a biomarker. And on the 4,000th try, when I was close to losing my sanity, I finally found one. It was called mesothelin, and it's just an ordinary run-of-the-mill type protein unless you have pancreatic, ovarian, and lung cancer, in which case it's found at these very high levels in your bloodstream. But the key is that it's found in the earliest stages of the disease, when someone has close to 100% chance of survival. So now that I found a reliable protein to detect, I moved on to actually detecting that protein and thus the presence of pancreatic cancer. Now, my breakthrough came in the most unlikely of places, my high school biology class, the absolute stifler of innovation. And I had essentially snuck in this article on things called carbon nanotubes. And these are really cool. They're essentially long, thin pipes of carbon that are an atom thick and 1/50,000th the diameter of your hair. However, despite their small size, they have these incredible properties, kind of like the superheroes of material science. So then we were supposed to be paying attention to these things called antibodies. You can imagine them like a lock and key. They only react with one type of protein. In this case, it would be the cancer biomarker mesothelin. And I was just sitting in my biology class when all of a sudden it hit me. What I was reading about carbon nanotubes and what I was thinking about antibodies could be combined. Essentially, you take these antibodies and weave them into this network of nanotubes, such that you have a network that only reacts with one specific protein. But also, due to the properties of the nanotubes, this network will change its electrical properties based on the amount of that protein present. In other words, I was pretty sure I had found a way to one day detect pancreatic cancer. However, there's a catch. Carbon nanotube networks are extremely flimsy. So since they're so delicate, I decided to use paper to support them. And making a paper sensor out of carbon nanotube is about as simple as making chocolate chip cookies. You start with some water, you then add some antibodies, add some nanotubes, mix it all up, take some paper, dip it, dry it, and you can detect cancer. And then all of a sudden it dawned on me, I needed a lab to do this research. So essentially what happened is I typed up a budget, a timeline, a procedure, and a materials list and sent it out to 200 different labs at Johns Hopkins University and the National Institutes of Health. And I kind of just waited, hoping that I was going to get like all these positive emails and I'd be able to pick and choose. And then reality took hold. I got 199 rejections from those professors. Some even going as far to rip apart my entire procedure line by line. I figured out professors weren't that nice at the time. So However, one professor said, maybe I might be able to help you. So I go into his lab armed with 500 plus journal articles after 3 months. And as soon as I sit down, he brings in some PhDs and they start questioning me. And then he calls in more and more and more. And they keep firing these questions. And by the end, there are 20 PhDs plus me and the professor all stuffed into this tiny room. It felt like a clown car almost. And luckily, I answered all of their questions. I guessed on quite a few of them, but I got them all right. And then once I gotten into the lab space, essentially I started working. And as soon as I got into the lab, I realized my once brilliant procedure wasn't nearly as brilliant as I had thought it would be. There seemed to be a million holes in it, and also I realized my ineptitude for culturing cells and doing the Western blot. I sneezed in my cells, I then tripped over them, and my professor wasn't too happy when that happened. But over the course of those 7 months, I finally did all this work and plugged each one of those holes in my procedure. And I ended up with one small paper sensor that costs 3 cents and takes 5 minutes to run. This makes it 168 times faster, over 26,000 times less expensive, and over 400 times more sensitive than our current standard for pancreatic cancer detection. And one of the best parts is that it can detect the cancer in the earliest stages, when someone has close to 100% chance of survival, and it has 100% accuracy so far. So in the next 2 to 5 years, this patent-pending sensor could potentially lift the once dismal pancreatic cancer survival rates from 5.5% to close to 100%. And it could do similar for ovarian and lung cancer. But it wouldn't stop there. By changing out the antibody, which isn't that difficult, you could potentially detect any protein. In other words, any disease, ranging from heart disease to Alzheimer's, other forms of cancer, and even HIV/AIDS. And so my hope for this sensor is that one day everyone can have a little bit more time with that one uncle, that one family member, that one brother, sister, relative. And through this, I've learned a very important lesson, that through the internet, anything is possible. Theories can be shared, and you don't have to be a professor with multiple degrees to have your ideas valued by others. It's a neutral space, where what you look like, age, or gender don't apply. It's just your ideas that matter. For me, it's all about looking at the internet in a whole new way, to realize that there's so much more to it than just posting duck-faced pictures of yourself online. You could be changing the world. So if a 15-year-old who didn't even know what a pancreas was could find a new way to detect pancreatic cancer, just imagine what you could do. Thank you.
Great job.
Just blows my mind. I mean, you look how he, loses his friend that he calls uncle, and realize that the needle hasn't moved in 120 years, that we're still in the dark ages. And with the internet, and like he said, it's that openness. The only way we are going to get movement here in the United States is we've got to work together. We've got to use our God-given gifts and talents to move, as Greg would say, the ball up the court. And by respecting each other, working together, putting all the walls down, I tell you what, for your generation, I foresee a lot of hope on the horizon, because that's what it's going to take. And your generation is going to be the one that's going to be out there empowering all this energy. And again, it's good stuff. So what I'd like to do now too is introduce Dr. Ziyan Zhang. He is University Park's one of their top cancer researchers. I had seen an article again in the newspaper at the Altoona Mirror about Penn State researcher receives a grant of $720,000 from the American Cancer Society for his cancer research. So it is my honor and privilege also to introduce Dr. Ziyan Zhang. Is this mine?
Thank you, Casey, for the introduction, and it's my honor to be here. So I am an assistant professor at Penn State University Park campus. I'm in bioengineering department. So my lab actually developed technologies Particularly, we are developing micro and nano technologies for biomedical applications. So one of the three major thrusts in my lab is actually developing technology to detect circulating tumor cells. So as we already know, over 90% of the cancer patients died because of metastatic tumors. Okay, so normally it's not the primary tumor that kills the patient, but when tumors started to spread around the body. Okay. And to get things complicated, this process is a very complicated process, and it can take decades. Okay, so currently, a lot of people believe, even from the right beginning of the primary tumor, this kind of metastasis process already started. Okay, so a lot of times when the patient is diagnosed with the primary tumor, and if the patient was told it's metastatic, that really means that process has been going around inside the body of the patient probably for many years. Okay, so by that time, it's very likely there are a lot of those so-called micrometastases. It's just a deposit of a very small number of tumor cells all around the body. Okay, so you can imagine the challenge will be, although we can remove the primary tumor, okay, so that can be done with a lot with surgical procedures, but then those micrometastases, those cell deposit, can actually come back even years or decades later. Okay, so that's kind of really the challenge. The other challenge for cancer research or cancer treatment is really cancer is not just a single disease. Okay, it has over 200 types. So even just we say, okay, breast cancer, for example, or maybe pancreatic. I'm not an expert in pancreatic cancer, but it's probably you have different types. We have different types, right? So it's very unlikely the cancer will be able to be treated by just one single drug. Okay. So I believe one of the potential solutions for cancer is trying to do personalized cancer treatment or diagnosis. So what I mean is, if we really know what's going on within the patient for one particular patient, at the cellular and the molecular level, what is going wrong with that patient, then it's very likely, hopefully with the help with cancer drug development, we can use more targeted drugs to correct this kind of particular defects within the patients. So hopefully by doing that, we can improve the treatment and the survival rate of patients. Okay. So go back to my own research. We are trying to develop one of those technology. So during cancer metastasis, what happens is those tumor cells will start to detach from the primary tumor or the original tumor. And then they're going through a complicated process. So the cancer cells will move into either the bloodstream or the lymphatic circulation stream. Okay. So through this circulation system, those tumor cells, most of the cases, they are individual tumor cells. Occasionally, they can be clusters of those tumor cells. So they will be able to move around across the body of the patients and deposit a distant tissue or organs. Okay. So when we look at this, I think in the circulating tumor cell community, we think if we can really detect these circulating tumor cells just from a tube of blood from the patient, and then we can study these tumor cells, we'll be able to learn a lot about the tumor itself, and hopefully give specific instruction for the doctors so they can treat the patients better. Okay. So it's a little bit different than the technology Jake was talking about, because he was trying to detect biomarkers inside the blood plasma. Okay, so proteins inside blood plasma. We are trying to look at the rare cells. Okay, so those circulating tumor cells. Okay, so though it turns out those circulating tumor cells, they are the majority of the tumor. Actually, 90% of the tumor are called so-called solid tumors. Okay, so they are from epithelial type of tissues. So they are inherently different from blood cells. Okay, so there are difference we can explore. We are trying to develop a technology to do the separation based on physical principles, so size and deformability, how the cells can be deformed, how flexible are those cells. Okay, so pretty much what we do is we develop a micro nano fabricated filter. So you can think, you probably use some of those filters. So it's basically just a membrane with very small holes or gaps on this membrane. Okay, so for the particular device we are actually making this filter on a 10 micrometer thick polymer membrane. And the critical size, or if we make a pore, the size of the pore will be between 5 to 8 micrometer diameter. Okay, so you can imagine we have thousands up to millions of those pores even on the 1 centimeter by 1 centimeter device. Okay, so that's what we are doing. And then we also need to develop engineering system, basically a small instrument prototype, so that we can actually filter a whole tube of blood through this device within about 2 minutes. Okay, so if you think about it, it's pretty fast because the surface area of this device is only 1 centimeter by 1 centimeter. Okay, so the challenge for this application is really these cells are very rare. So 1 tumor cell out of 1 to 10 billions of blood cells. So we are really looking for a needle in a haystack. Okay, and then so this is so-called enrichment process. So basically, these tumor cells are larger and a little bit more tougher to be compressed than the blood cells, even the white blood cells. Okay, but unfortunately, after this just single step, we won't be able to get pure tumor cells on the device. Okay, so there are still some relatively large white blood cells. For example, macrophage, they can be relatively large. So they are still on the device, right? So on average, after this filtration process, we still have for 1 tumor cells, we still have around 100 to 1,000 white blood cells. So the next step, we need to do so-called immunocytochemistry staining. Basically, we need to apply antibody to this system, and the antibody is conjugated or connected to a fluorophore. So it's like a photo dye. Okay. So after that, we will be able to see those tumor cells. So we will be able to count them right now under a microscope. So hopefully later, if this move to become a commercial application, we can actually make a portable optical detection system, so that can be done in a more effective way. Okay, so far I started working on something like this from 2005. So when I was doing a PhD and postdoc study at Caltech, and then after I moved to Penn State, I developed a newer technology based on this principle. So far, through collaboration with some oncologists, I guess we spend a lot of effort trying to get blood samples in. So nowadays we have tested about 30 to 40 patient blood samples, and we do see very good results. So that's why we will be able to use those preliminary results and get funding from American Cancer Society. So we're pretty lucky to get that. So I think as we said before, cancer, from the U.S. government and the community has already made a lot of resources and effort in trying to combat with cancer. But cancer is a very complicated disease, especially if you think those are really the cells from our own body. Right? So it's very difficult to really tell those enemies from the friends or normal cells. So far, I think there's still a long way before we can really say we can cure the cancer. Okay, so that's why I think an opportunity like this will be very, very extremely helpful. So we can bring you guys, the young people, really the hope for something. We can move this field forward. We can do better research. We can get a wider awareness of this problem, and hopefully, with all these efforts, with the doctors, researchers, patients, and the whole community, we can actually move it forward. Hopefully, after probably decades, we'll say we can cure the cancer. Okay, thank you.
Thank you. So as you see by our three panelists, it is all a collaborative effort, and that's why we have you here today, that we're all in this together. So I want to take the opportunity to thank Donna Bond and the Sheets Entrepreneurial Center, and I'd like to give them a round of applause for having us here. And I have two special ladies with me that this event wouldn't happen if it wasn't for them. I'd like to call Caitlin Farnan up first, please. Caitlin is a cancer survivor that works at Penn State Altoona, and she has been the heart and soul of this entire April 5th event. We could not have done it without Caitlin, and so I'd like her to tell her story.
Good afternoon. Some of you have had a lot of privilege to know just through teaching or through working with Enactus, so it's good to see you guys all here. But the interesting part about my story was I was pretty much a healthy 14-year-old until one day I ended up in a trauma center. And 1 week later I found out I had cancer. Before that point I'd had 6 family members who have died of other different types of cancers, so it kind of seemed like a little interesting, but I said, no, don't worry, I'll still be here. 10 years later, I still am. I'm now 24 years old. I've defied the odds twice of surviving the type of end stage of colon cancer I had. So I was told, and since then, my doctor, who told me not to be too optimistic down in Pittsburgh, has since then seen my high school graduation announcement and my college graduation announcement with little sticky notes on it that say, God 2, you 0. Which he loves and then promptly puts up in his office, which I can still tell you to this day they're still there. Now I've had the privilege of working with them, but my background really isn't in biology or science or cancer research. My background's in politics, economics, national security and counterterrorism, and linguistics. But I went up to Mrs. Griffith one day, we've had the privilege of knowing her for years, and I said, I've got an idea about how you can take this community foundation and make it bigger. And since then, she's been kind enough to indulge me. And here we are today. So the moral of the story is that if you have enough perseverance, you can pretty much defy any odds that are out there. Because the funny thing about odds is they only really predict past events. They tell you what's already happened. They don't really tell you what's going to happen. So you really don't have to live by those statistics, those strange little funny figures, if you don't want to. Put your mind to it, dream huge, work harder, and you can pretty much accomplish anything you want to. You need to think about your situation as you guys are at Penn State Altoona. So you have a wonderful faculty here that are more than willing to help you. I started out at Penn State Altoona, and I went up to my economics professor one day and said, hey, I have a cool idea for a research project having to deal with how can we teach education. And it didn't take 200, so it's not that impressive, but she kind of said, all right, let's see where we can go with this. And 6 months later, I was presenting my new theory on education in Nagoya, Japan. So you guys really have the talent and the capability here that you could do anything you wanted to. And we have the faculty here who I know, because I work with them, and I am one of them, who are more than willing to back you up and say, hey, let's see how we can get this done. So you can wake up every morning, hit your alarm, just go to class, and then go home and take your exams. Or you can figure out how you can use your talents and change the world.
Amen.
The choice is yours.
Amen to that. And then I have another wonderful friend, and her name is Kiera Sheardon. She's a 6th grader, Juniata Gap Elementary. Come on up, Kiera. She is our official ambassador of our Griffith Family Foundation and our Alliance of Families Fighting Pancreatic Cancer. She is also a cancer survivor, and she has epithelioid sarcoma, and there is only 100 cases of this worldwide. And Kiera was diagnosed a couple weeks before Greg. And Greg and Kiera became very good friends, and we've been kind of joined at the hip the last 3 years, and where we go, she goes. And okay, yes, so you can see her, she's hiding. So Kiera, I want to tell you a little bit about Kiera. I can't keep up with Kiera. Kiera has traveled internationally to Medjugorje, Bosnia on religious pilgrimages. She's in the orchestra. She is a crossing guard. She plays the piano. She plays the violin. I mean, I could go on and on and on. Kiera also, like Jack, like Caitlin, she is an innovator that's rocking our world. And Kiera, I am so proud of. And would you like to say a little something to everybody? Go ahead. Do you want to? No? She's quiet right now. Wait till tonight. We have an event tonight. She'll probably get a little more talkative. She usually has things to say, but today I think she's just taking this all in and enjoying being here. So can we give Kiera a round of applause? Good stuff. Good stuff. So, you know, this is basically what we do at the Griffith Family Foundation is we connect people. You know, we call ourselves, we're cancer warriors. Our true mission is pancreatic cancer, and it always will be, because that's what, you know, we raise our dollars for, is for Dr. James Moser's pancreatic research up at Harvard. He formed this alliance of families fighting pancreatic cancer. And this alliance is a lot of families, like the Griffith family, have united. And we've decided to raise the dollars and give it directly to Dr. Moser, the researcher, bypassing kind of the institution, again, changing the thought process of how we raise our dollars and what we do with our dollars. And that's what we're going to announce tonight at the DeVoris Center, is the Alliance of Families Fighting Pancreatic Cancer, and our new grassroots effort of raising money to go to research team like Dr. Moser's. So what we're going to do right now, I know you guys all probably have a lot of questions, so we're going to open this up to a panel discussion for these three wonderful gentlemen, so feel free to start asking questions. Yeah, it's tons of questions.
So this is for Jack, actually, and I guess the other two gentlemen. So now that you guys have sort of developed that technology, you've discovered that the potential is there, what's the next step in sort of testing?
So with my technique, what has happened is I actually own the international rights on it. And I'm actually in talks with large pharmaceutical companies such as Quest Diagnostics and LabCorp about getting it through the FDA process and getting it on the mass market as soon as possible. And fortunately enough, they are helping me expedite it through the sFDA through knowledge of the HR bills. What was the number? 733. Yes. So it will be on your local Walgreens shelf in like the next 2 to 5 years, and then also it will be used in your like annual doctor's clinic. And hopefully what the goal is by developing more of these sensors for these different types of diseases, really you would be able to answer a survey on like your smartphone, for example. Say you're feeling sick. You'd be able to take your smartphone, answer a few questions, and that would say go to Walmart or Walgreens or wherever that place is, and essentially pick up this pack and just test yourself, and you'd be able to instantaneously, from the comfort of your own home, diagnose any disease.
Some more questions?
This question is probably more for Dr. McKibben. What do you see is the greatest opportunity, perhaps, for education and awareness in our area in central Pennsylvania? I know you said you have an outreach of about 500,000 at Blair Gastro. So what's our greatest opportunity? I know a lot of us in this row at least are nurses, so what can we do, or what do you see as the greatest opportunity moving forward?
Well, I go back to the model that was presented about change. Obviously, you have to increase awareness that this is actually an important cancer because it is the number 4 cancer killer, and it is one of the future ones that you have to worry about. Using the social networking models to increase awareness and spread information The idea would be that you're all deputized today to go out and tell people to think about it, and there's 6 degrees of separation between you and anyone else on the planet. So that's the first thing. In other words, just increasing awareness. The second thing in our practice, what we're doing is we're instituting a model to start following and tracking people with pancreatic disease. It's a complicated story, but you know, as you know, healthcare people are human beings, and we have our prejudices and biases, and you take classes on how to get along with people from different cultures, etc. Well, there are diseases that are socially acceptable and others that are not. I always say socially acceptable starts at the neck and becomes less acceptable as you go down. So you can show off your bypass scar at a party, but you probably can't show your hernia scar, if you know what I mean. So the idea then is to change the thinking in the healthcare profession. Pancreas disease, at least chronic pancreas inflammation, was always thought of as an alcoholic's disease. If you say to someone, you have cirrhosis of the liver, people say, oh gosh, I didn't know he drank. But we all know now there's hepatitis A, B, C, well A doesn't do it, but B and C and immune diseases and all kinds of things cause liver cirrhosis, which simply means a lot of scarring. The same thing with the pancreas. We now know there are lots of inflammation diseases, hereditary diseases, and things like that that we didn't know about, and there's an inherent bias in the community. So we will change our practice methods and methodology, institute a database, a tracking system, and try to spread the word as quickly as possible by reaching out to people. We don't want to use the old model. I always called it, trying to convince one person at a time in my office. How many people can I see? You know what I mean? So I'd rather go out in the community and increase awareness. This is something that I've been doing for years, initially with colon cancer prevention. That's really on track at this point. So moving on to other diseases. So increased awareness, decrease the bias, increase your self-awareness, so to speak, and take it from there.
One thing I would like to add is I know that the AFFPC is launching this thing called the Sideline Cancer, where, for example, you'd raise money for these different cancer organizations, and 50% would go to the AFFCP. Did I get that right? PC, or yes, and then also 50% to a cancer charity of your choice. So that would definitely be a great opportunity to educate others as well as raise funds for this research.
If this was answered, but
What is the process of detecting, like for the home kit? Is it like a diabetes or a kit, like where you just prick your blood, and how much would you need?
Yeah, so actually what happens with this is it could be either a urine test or a blood test. So it's essentially like a diabetes test strip, and really what we're working towards is a glucometer setup, but for pancreatic cancer. And you only need 1/6 of a drop of blood. So just imagine a diabetes test strip that takes a drop, you just need 1/6 of that.
Just as an aside, those who are old enough to remember, which is nobody besides the panel, I think, testing used to be complicated. He was talking about growing cells and having problems, etc. So testing was always a regulated thing. You had to go to the lab had trained technicians and they were licensed, and it cost a lot of money to run a lab. Well, we now have urine pregnancy tests, you just do the dipstick, etc., which is a really relatively new phenomenon in the history of the world that you can do these things. So this is sort of a new generation test that doesn't require the expensive overhead. Now it's not out yet, but that's the idea. How can this be versus the other? Think of it as the pregnancy test for cancer, so to speak.
So do you think that this will be something that doctors will routinely test for now that it's increasing in prevalence and it's so hard to detect, and just being that you're healthy until, you know, you find out that you're so close to death? I mean, do you think it'll be something like a normal, let's do a CBC and we'll just do this test?
Yeah, so what a very interesting statistic is that in the next few years, pancreatic cancer mortality will raise by twice. So it will go from around 50,000 to over 100,000. And so these tests will definitely become more prevalent. And it would literally be, you could, since it's just a sixth of a drop-in, it costs 3 cents, you could pretty much test every single day of the year for less than $10 almost. And so, or actually, did I do my math right there? Okay. Around there. Yeah, so that's essentially what's going to be the future. And really what we're also working towards is I've also gathered a team of all high school students, and they're all-star researchers from around the world, and we're working on actually advancing this technique to the next level. And essentially we're entering a competition called the Tricorder X Prize for $10 million. And it's to develop something the size of a smartphone that you just pass over your skin and it will diagnose any disease instantly, as well as monitor 5 vitals 30 times per second. And so I'm working on something the size of a sugar cube that will look through your skin into your bloodstream and from there diagnose any disease by looking at every single protein. Wow. So that's the future of medicine.
But who is it?
One more. Yep, one more.
This one's for Jack. You're 15. Do you have time to be a kid?
Correction, I am 16. No, just kidding. It depends on your definition of kid. Before this, I was still in the lab, and sometimes I would stay in the lab until 2:30 in the morning. I suppose that's my idea of fun. I'm a bit strange in that perspective. However, I do normal stuff. I might go to the movies every now and then with my friends, but it's an interesting change from my normal life because now I don't go to school nearly as often.
And you're a kayaker?
Yes, I actually am on the National and Junior Wildwater team for kayaking, so I still do kayaking. So, normal life.
As much as it can be. Yeah, and hanging with the Obamas. He was Michelle Obama's guest at the State of the Union, and he met with the Secretary of Education, Dr. Arne Duncan. You know, you're doing the science, technology, engineering, math, they call it STEM. You were on that panel down in DC, and you know, he's internationally all over the place. So, you know, he definitely got out of the boat, you know, like he was thrown out of the boat. So, you know, I'm proud of him. I mean, this event, we have, like I said, he'll be speaking again tonight at 7:30. If any of you, you know, we have Dr. Moser will be here tonight. If you'd like to come and hear him speak, and we have another pancreatic surgeon. Her name is Dr. Melissa Hogue from UPMC. She will be here tonight also, and we will be making our official announcements of the Alliance of Families Fighting Pancreatic Cancer. So one more thank you I have. A very special lady in the back, Mrs. Jane Andraka. Let's give her a round of applause. I want to thank everybody for, you know, this wonderful afternoon. You can follow Jack. Tell them how.
On Facebook and Twitter, so
Please
follow me.
Follow him. You can keep, I tell him I stalk him.
Instead of doing keeping up with the Kardashians, you can be keeping up with Jack.
And this is so much better than how their nails and hair are. This is where it's happening. So, you know, by opening your eyes and seeing what's happening in our world, follow. I mean, just follow what's happening, and you go out and make your difference in the world too. Thank you.